All right, let's jump right in. Today, we're going to break down one of the most powerful ideas behind all the AI that's shaping our world, neural networks. So, let's get to it. You ever stop and think about your email inbox? How it just knows what's junk and what's actually important? It really feels kind of like magic, doesn't it?
Or, what about your phone? How in the world does it unlock in less than a second just for you by simply glancing at your face?
And it's not just about security. Think about your streaming app. How does it get so creepily good at recommending the perfect show for you to binge next?
The secret sauce behind all of this isn't just a giant list of if-then rules somebody programmed. Nope, it's something way more interesting. It's a system that can actually learn. Which brings up the real question, how does a computer even do that? And that's our first big topic. Is it really possible for a computer to learn and start making its own decisions? How does that even begin? Well, at the very heart of all this is something called an artificial neural network. And the core idea, which comes from our source material, is that it's a model designed to make decisions a lot like the human brain does. That's really the key. We're trying to build a machine that, in a small way, kind of thinks like us.
So, to really get how they work, we have to start with the original blueprint, that incredible, complex network of neurons inside our own heads. Let's look at how that inspiration took shape.
Okay, so check this out. On the left, you've got a real biological neuron. It has dendrites to receive signals, a body to process them, and an axon to send a new signal out. And on the right, that's the artificial version. The inputs are like the dendrites, the main node is like the cell body, and the output is the axon. It's a really simple but incredibly powerful mirror of biology.
Now that might still feel a little abstract, I get it. So let's bring this all down to earth with a super simple, everyday decision to see how just one of these artificial neurons actually works.
All right, let's imagine you're at the beach. You've got a choice to make. Is today a good day to go surfing? A single artificial neuron can totally handle this decision. So to make that call, you'd probably think about a few key things, right? These are going to be our inputs. Number 1, are the waves any good? Number 2, is it super crowded out there? And number 3, a pretty important one, has there been any recent shark activity? Now here's where it gets really interesting, because not all those factors are equally important, are they? So we give each one a weight to represent its importance. Good waves? That's a huge deal, so we'll give it a high weight, say a 5. A crowded lineup? That's less important, so it gets a 2. And shark activity? Yeah, that's pretty darn important. Let's give that a 4. And that right there, that's exactly what a single neuron does. It takes each input, a simple yes or no, a 1 or a 0, multiplies it by how important it is, its weight, and then just adds it all up. If that final score is high enough, the neuron fires and sends out a heck yeah, go surfing signal. If not, it's a nah, not today. It's just a tiny little calculator making one simple choice.
But a single calculator is one thing. The real magic, the real power, happens when you start connecting a whole bunch of these simple decision makers together. That's when you get a real network.
See, one neuron can only make a simple choice. But when you line them up in layers, like this, an input layer to take in the data, these middle hidden layers to do the heavy thinking, and an output layer for the final answer, they can solve incredibly complex problems. The decision from one whole layer of neurons just becomes the input for the next layer.
So you might be wondering, okay, but how does it actually get smart? Well, this is the most brilliant part of the whole thing. It learns through a process called backpropagation. Just think of it like this. Every time the network gets an answer wrong, it sends a little correction signal backwards through all the layers, and it slightly adjusts all those weights, the importance factors we talked about. It is literally learning from its mistakes, getting just a tiny bit smarter with every single try.
And that whole process, learning from mistakes, but scaled up across millions of neurons doing it trillions of times, that is what powers the incredible AI we all use every single day.
Take the AI that understands pictures, for example. That's usually handled by a special type of network called a convolutional neural network, or a CNN. You can think of it as the network's vision system. It's built to recognize patterns, edges, shapes, colors. This is how your phone finds faces in photos, but on a much deeper level, it's what lets AI help doctors find patterns in medical scans that a human eye might just miss.
And then you've got the networks that understand language and speech. These are called recurrent neural networks, or RNNs. Think of these as the network's ears and mouth. Their whole specialty is understanding things that happen in a sequence, where the order of things is everything.
An RNN actually remembers what was said earlier in a sentence, which is absolutely crucial for things like real-time translation or for the chatbot that's helping you with your online order. They don't just see words, they get the flow of the conversation.
So when you put all this together, these different kinds of networks are making our digital world way smarter and more helpful. Because they can learn and adapt, we get better accuracy, things become more efficient, and we get those super personalized experiences that just feel seamless. Whether it's movie recommendations or driving directions, they're basically becoming the invisible engine that runs modern life.
Of course, with any technology this powerful, it also brings up some really big, important questions we have to talk about. As our source material points out, we have to think really hard about things like data privacy, the very real challenge of making sure these systems are fair and not biased, and what all this automation means for the future of jobs.
And that leaves us with one last fascinating question to think about. These networks learn from the data we feed them. In a way, they're a reflection of us, of our priorities. So as they get more and more powerful and woven into the fabric of our world, the most important decision we all have to make is, what exactly should we teach them next?